Okay, this is the second lecture dealing with creating decisions in Java, and we're going to expand a little bit on the types of conditions that we can write. This time what we're going to do is look at situations where we will write conditions in our code where multiple decisions need to be made, and the two main terms which are used for this type of decision are either compound conditions or compound decisions. I'm going to look at some examples of those in a minute, but for compound decisions to actually be used, we also need to be aware of these things called logical operators. You've probably seen them and used them in other languages. They may be similar depending on the language you've learned, or they may be different, so we're going to look at those as well. There are basically three, and you probably know them by name. The symbology might be a little bit different. So in the first example here, we've got an example of a logical OR. If you remember, a logical OR means that either side of the condition can be true in order for the entire statement to produce a true. It also will produce a true if X and Y are both true. These are the symbols that are used for a logical AND. And for an AND to produce a true, both sides of the condition must be true. If either side is false, it will produce a false. In this particular example, this is an example of a logical NOT, and a NOT basically inverses. So if the value in this example of X is true, the inverse of X will produce a false. If the value of X is false, the inverse of X will produce a true. So here's something to give you a bit of practice. We've got two integer variables, one called I1 with 10 in it, one called I2 with 5 in it, and we've got some compound decisions. They use OR, they use AND, there's even a NOT in there. They also incorporate some mathematical symbols and greater than and less than symbols that we've learned in previous lectures. So what I need you to do is basically transpose the values of these variables, 10 and 5, into these, and then ultimately make a decision as to whether the final outputs of these compound decisions will produce either a true or a false. So what you need to do, just pause the video, take a few minutes, have a go at those, and then we'll go through the answers. Okay, and this is what we've got. Let's just jot down at the top the two values. If we remember that I1 is equal to 10 and I2 is equal to 5. So let's transpose those values into these and see if we actually come up with our answers. So when we look at these, we try and work out both sides, and then we do the logical operator last. So let's remember, I1 is less than 12. Well, I1 is 10. Is 10 less than 12? Well, that produces a true. Is I2 less than 3? Well, I2 has a value of 5. So is 5 less than 3? Well, ultimately that produces a false. So a true ORed with a false. Either side of an OR needs to be true in order to produce a true, so the answer is true. Moving on to the next one. Again, I1 has a value of 10. I2 has a value of 5. in this particular case, is I1 less than 8? Well, 10 isn't less than 8, in which case that's got to be a false. And is I2 greater than 0? Well, is 5 greater than 0? We know it is, so that's a true. Rules of an AND are that both sides of an AND must be true in order to produce a true, but in this case we've got a false on one side, in which case the answer has to be false. In this last one, or the next one, let's transpose the values again. I1 is 10, I2 is 5. Is 10 greater than 5? Well, we know it is. But we have a not, and the not of a true is false. Now the examples are getting a little bit bigger, so we just need to be a little bit more careful. So we'll deal with this side, I1 plus I2, which is 15, and I2 times I1, which is 10 times 5, which is 50. So the condition is I1 plus I2 is 15 greater than I2 times I1, which is 50. Is 15 greater than 50? Well, it's not. It's false. But we have the not, so the not of a false produces a true. And this is the more complex one, but again, let's go through it one bit at a time. So again, transpose the values. I1 is 10. I1 is 10. I2 is 5. Let's just go through those one at a time. Is I1 greater than 5? Well, 10 is greater than 5, so we know that's true. Is I1 less than 9? Well, is 10 less than 9? No, so that's false. And in this one, is I2 greater than 0? Well, is 5 greater than 0? Well, we know that to be true. Now what we've got to do is make our final evaluations based on the brackets. Now, we've actually got our brackets here to indicate which ones need to be done first and second. And obviously, because we've got these two sets of brackets on this left-hand side, we can evaluate the AND for these two first, then OR our result with the right-hand side. So in this case, we have a true ANDed with a false. What that means for us is that with the rules of an AND, that both sides need to produce a true in order to output a true. So a true ANDed with a false produces false. Looking on this side, we've already got our true, and in between we've got our OR. Rules of an OR is that in order to produce a true, either side can produce a true. We've got a true on that side, so false ORed with true produces a true. Okay, so let's have a look at a Java-based equivalent of that. Very short piece of code, but we've got a compound decision in there, and the two sides indicate if the variable m long dist or long distance calls is 0 and m local is 0. In context of the program that you're going to be demonstrating in a minute, it basically identifies that if the number of long distance calls is 0 and the number of local calls is 0, so if both sides are true in order for the AND to produce a true, then it will tell us that we made no calls. Obviously, if that's not the case and these two values are clearly different than 0, it will tell us that we've made some calls. So let's have a look at the first program in the phone. and we'll see how that works. Okay, so I've downloaded the project called Phone from the VLE. I've already opened it up in BlueJ, and I've already compiled it just in case there's any problems with it. So let's open that up in the editor and let's have a look at the code. Not particularly big program, so let's just have a look at the class. There are two instance variables which are both integers, one for long distance calls and one for local calls. In the constructor, they're both initialized to 0, and then we've got two methods. If we make a long distance call, we add one on to the long distance variable. If we make a local call, we add one on to the local calls variable. And in the call count, if we don't make any long distance calls and don't make any local calls, it'll tell us we've made no calls. Otherwise, it outputs two user messages which tells us how many long distance calls we've made and how many local calls we've made. So we'll do a quick compile and we'll create an instance, and let's just inspect it, and then let's count how many calls we've made so far. Now, with both of those equaling 0, it should tell us that we made no calls in this month. If I make one local call, the situation will be that both of those, well, long distance still equals 0, but local now equals 1. So if we do a call count now, it will tell us that we made no long distance calls this month, but we made one local call. So, a popular question that always gets asked around the use of compound decisions and logical operators is, when do we use not? Because not has a logical inverse, and that can be seen with the example here at the bottom. We could say if not age is greater than 10. Now, anything that's not greater than 10 must be less than or equal to it. In which case, why can't we just say age is less than or equal to 10? And there's actually no right and wrong answer. If you feel that you want to write age is less than or equal to 10, then that could be the most meaningful version depending on the context of the program that you're writing, and it's absolutely perfect to use. If, however, you feel you want to use the not symbol and to ask for the inverse of anything greater than 10, that's perfectly fine as well. So don't try and get all het up about the notion of when to use not or when not to use not. They're effectively the same thing. So let's develop our use of compound decisions with our window cleaner example. So we've got a bit of a problem, because when Wendy finishes cleaning all the windows, she actually calls Bill and reset. She leaves the cradle, but the problem that we've got is that there's actually currently no restriction on when she can actually leave the cradle. So logically, she could exit the cradle on the top floor. So we need to basically add some kind of a decision so that we only allow Wendy to open the cradle gate when she's actually on the ground floor. So we have to look at a situation where we have to measure the state of the cradle gate. It can either be open or it can be closed. So what we're going to do is, we could, if we wanted to, use an integer, and let's say we could say 0 for closed and 1 for open. Those of you who've programmed before will obviously realise that there's a different way that we can do that, and we're going to look at a new data type which will allow us to take only two values, and that data type is the Boolean. If you haven't come across Booleans before, they're basically variables where they can only hold one of two values, one being true and one being false. To declare a Boolean in Java, we can actually use the word Boolean. The way that we're going to do it is we're going to declare a Boolean data type called gateOpen. If the value of gateOpen is true, we're actually going to use that to represent the gate being open. If the value of gateOpen is false, then we're going to assume that the gate is shut. So let's have a look at that now. Okay, so I've got the example called gate downloaded from the VLE. I've compiled it just to make sure that there aren't any errors. So let's have a look at the code in the editor. Okay, so what have we got? Well, we've got the class, and we've declared our instance variable gateOpen as a Boolean, and in the constructor we've initially set that to true. If you remember from the previous slides, I've actually said that if gateOpen is true, the gate is open. We've got a method called openGate. If we open the gate, we set gateOpen to true because it's already open, and if we close the gate, we need to set gateOpen equal to false. So let's give that a quick compile and create an instance of a gate and inspect it, and let's just call the methods to see how the value changes. At the minute, the gate is currently open. If I attempt to open a gate that's already open, it just stays open, it's true. If I close the gate, it sets it to false. If I try and close the gate when it's already closed, it stays at false. If I open the gate, it sets it to true. Now you might notice, maybe in these notes, you may notice them in other notes that you might see if you go doing your research on the internet or in books, that sometimes testing the state of a Boolean using an if statement can be written in different ways. There's actually a short version of it. You might be used to doing something like that, where you say if the value of mgateOpen is equal to true. That's perfectly alright to use. You can also just use the name of the variable, and it actually implies that you're testing to see if that is true. Both of them are perfectly fine to use. You can also do a similar test on the value of mgateOpen being false, and again there's what I would call the longhand version. Might be the longhand version, but still it's a perfectly normal way of testing it. So if mgateOpen is false, or you could just say the inverse or the not of mgateOpen. So what you're doing is just testing for the mgateOpen being not true, but inverting it to make it false. The shorter form generally is preferred. I certainly don't think your computer will catch fire, or I don't think you're going to get arrested for using the longhand version. But if you feel more confident, then there's no reason to test a Boolean using the shorter form. So let's try and put that in a little bit more context, and let's look at the gate2 example. Okay, I've downloaded the example gate2 from the VLE. I've just extracted it, and I've just given it a quick compile just to make sure everything's alright. So let's open the editor up and have a look at the code, and just see that it's just been expanded a little bit. Again, we've got the class, this time it's called gate2. We've got our Boolean declared for gateOpen, and in the constructor the value of gateOpen is set to true. Open gate and close gate are the same. If you open the gate, you set gateOpen to true. If we close the gate, we set mgateOpen to false. But we've added a new block of code, we've added a new method called display status, And what we're doing is we're actually demonstrating that we can test for the state of mgate open, and if mgate open is true, and that's the shorthand method, if it's true, we say the gate is open. If that's false, then we display that the gate is closed. So let's just test that to see that it works. And we'll create an instance and inspect it. So let's see how that works. At the minute, the gate is currently open. So let's display the status, and it tells us that the gate is open. If we close the gate, mgate open is set to false, and we'll display the status again, and it now tells us that the gate is now closed. So let's have a look at how we can actually install our gate mechanism now into our window cleaner class. First thing we're going to have to do is we're going to have to add a boolean mgate open, and we're going to start the system with the gate open. So like in the previous example, we're going to put mgate open into our constructor and set it to true, and in our close gate method we're going to call that when Wendy actually enters the cradle. So she enters the cradle with an open gate, and then we'll call close gate in order to shut the gate behind her. Obviously we're going to have to put some health and safety checks in there. So when we call the go up method, we're going to have to check the value of mgate open, because she's only going to be allowed to move up in the cradle if the value of gate open is set to false. Otherwise she's going to be moving a gate up the side of a building with the cradle open, and we don't want that. So here's the close gate method, which we've seen in the previous example, which we just set to false. And here's the go up method. In the go up method, we've now got a decision. So if the value of mgate open is true, we will tell the user we can't move the gate, we can't move the cradle upwards with the gate open. If the value of mgate open is false, then we'll actually be allowed to move the cradle up a floor. So let's have a look at that working. Okay, so I've downloaded the example window cleaner 3 from the VLE. I've extracted it, opened it up in BlueJ and run a quick compile. So let's just open it up in the editor so we can examine the code. And this version has got some tracking elements in there. For this version or this demonstration, we're just going to look at the checking of the status of the gate in terms of the go up method. We're going to look at it again in a short while to examine another part of the program. So at the minute, the version that you're looking at contains all the previous changes, incorporating base charges and floor factors to charge customers, the changing of current floor, the calculation of total charge, all the things that we looked at, for example, when we wipe the window and bill and reset. But in this particular example, at this time, all I want to do is just examine the checking of the gate mechanism in the go up method. So first of all, we've declared our boolean mgate open, and in the constructor I've initialized that to true. So when we create an instance of a window cleaner, the cradle's in place with the gate open. In the go up method, here's our check for an attempt to move the cradle up the building, and if the value of mgate open is true, the gate is open, so we tell the user they can't go up with the gate open. If that value is false, then we can allow the cradle to move up a floor. So let's just compile that and have a quick look, and we'll just check the status of the cradle, and there's our value with mgate open there. So at the minute the gate's open. If I attempt to go up, first thing I'll get is a message saying I can't go up with the gate open. So what I'll attempt to do is then close the gate. That's set to false, and if I call go up, it now allows the gate to move up the building because the cradle gate is now set to closed. Okay, so let's try and expand on this a little bit. Give you a little task to perform. So what we're going to do now is think about writing a method that's going to allow us to open the gate. Now clearly, if the cradle's not on the ground floor, we shouldn't allow the gate to be open. You don't open a gate several floors above the ground. So what we need to do is implement a method called openGate, which will give us an error if the cradle is actually above the ground level, i.e. the current floor is greater than 0. As well as that, it needs to set mgate open appropriately if the cradle is on the ground. So if we attempt to open the gate on the ground floor, it will then set that to true. Have a quick go at that, and then we'll have a look at a possible answer in a second. Okay, so here's an example, or one example that you can use. Method called openGate. If the value of the current floor is greater than 0, we can then tell the user that we can't open the gate above floor 0. If the value of current floor is equal to 0, then we can actually open the gate. So what we can do is we can try and plug that functionality into our existing window cleaner class, but we're going to do this in a slightly different way, because what we're going to do is we're going to get one method to call another method. That's a little bit different than what we've done before, because we've always invoked a method by right clicking the instance of an object and calling the method from there. So the way we're going to do it is plug this functionality into our existing program. So we're going to get a method to call another method in the same class. And the way we do that is we're going to basically say that Wendy will always want to call bill and reset for the final price when she finishes the job. Now we can do that automatically. We could right click the instance and call bill and reset. But we can set the program to call bill and reset automatically, and we can do that when she actually opens the gate and leaves the cradle in the openGate method. And what we can do is basically call the method by its name inside another method. And once it's finished, it will always go back to where it's been called from. There's an example of how it would work. If we put it in the openGate method, we can say that in an attempt to open the gate and the value of m current floor is greater than 0 or above the ground, we can tell the user, no, we can't do that. You're above floor 0. You shouldn't be allowed to do that. But if the value of m current floor is equal to 0, clearly the gate is on ground level. We can open the gate and then call bill and reset, which will then mean that Wendy leaves the cradle and then she can automatically issue a bill. So we'll look at that particular functionality now in the same window cleaner 3 that we looked at before. Okay, so we've got window cleaner 3 open again. Let's open it up in the editor. We've already seen the changes that we've made to go up, but what we want to do is concentrate on the openGate method. Now, as you can see there, we've still got the old bill and reset method that tells the customer what the final bill is, and it resets the total charge back to 0, ready for the next customer. But what we want to do is we want to incorporate that functionality inside openGate. So when we have finished cleaning the windows, we want to be able to get out of the cradle and give the customer their bill. The way we're going to do that is incorporate it into the open gate method. So again, if the current floor is greater than 0, you can't get out because you're above floor 0. If you are on current floor 0, we can then open the gate, and then this call to bill and reset will run. And what it will do is it will call bill and reset, which is this, display the total charge for the bill, and then reset total charge back to 0. Once it's finished, it will go back to here and then close everything off. So you're actually calling a method from within another method. Let's see that at work. Let's give it a compile, and we'll create an instance, and we'll inspect. Alright, so we've got our base charge and floor factor, which we haven't altered. We've got the cradle on the current floor, which is the ground, and we've got no total charge yet. So let's go up 3 floors, back down again, but while we're above the ground, we'll try and open the gate. So first thing we'll do is we will close the gate, because currently mgate open is equal to true. So we're going to close the gate, and we'll go up a floor. We'll go up a floor, and then we'll clean the window. So it tells us that we're wiping on window on floor 1, and it's calculated the charge for that one. Let's go up another floor and wipe the window on that floor, and again it tells us wiping the window on floor 2, and it's calculated the cost of that. Let's go up one more and wipe the window, and again it tells us that we're wiping the window on floor 3, and it makes the charge accordingly. Now at this point, let's actually attempt to open the gate, and quite rightfully we're on floor 3 and we can't open the gate above floor 0. We could, let's try and go down a floor and attempt to open the gate again, and thankfully it's trapped that as well. So what we will do, let's go down to the ground floor. So we'll go down to floor 1, go down to floor 0, and remember what happened in the code. We're on the ground floor, we want to open the gate to get out and then present the bill to the owner of the building. So that means we're going to call open gate, it will open the gate, and then it will call bill and reset to present the final bill value to the customer, in which case we will attempt to open the gate. It's on ground, current floor 0. It presents the bill of 42p by calling bill and reset, and then it resets total charge, resets out everything else, and gets ready for the next building. Okay, so that's an example of incorporating compound methods with logical decisions, and now what we're going to look at is the ability to include decisions within multiple if statements, and we're going to do that by using these things called embedded decisions. Again, I think a lot of you who've programmed before will have used embedded decisions, have been taught embedded decisions, and one of the most important things when we use them is that we need to make sure that our code is laid out properly to make sure that it's easily readable and it keeps the meanings very, very clear. There's an example of a well-structured set of embedded decisions, and Thankfully, BlueJ does help by colour coding our decisions, as well as automatically indenting the code as well. But you can see here it's the alignment of the brackets that makes our code a lot easier to see. Here we've got the outer if statement, and here we've got the inner if statement, and you can see straight away how that would work. If that condition is true, we run everything in here. If that condition is false, then we run the else. Inside here, if that condition is true and that condition is true, we run that one. If that condition is true and that condition is false, we run that one. So what we're going to do is we're just going to look at a simple example phone call calculator. So let's have a look at the specification for this problem. We have a company, Phone It Limited, and they charge for their phone calls due to the rules below. If you make more than 5 long distance calls a month, then all your long distance calls are 10p each, and up to 10 local calls are free, and over 10 local calls are 2p. Otherwise, long distance calls are 25p and local calls are 5p. What we want to do is basically try and write a program which will display those charges. And it looks quite complex, but if we try and give it sort of a pseudocode approach, then what we can see is that by putting our English into our pseudocode structures, it's actually not as difficult as it makes out. If we look at the algorithm, we've got embedded decisions. So what we can say is, if more than 5 long distance calls are made, then we set long distance calls to 10 pence. If less than or equal to 10 local calls are made, then they are free. But if we make greater than 10 local calls, we charge them at 2p each. If less than or equal to 5 long distance calls are made, then long distance calls are 25p and local calls are 5p. And that's the same thing translated into Java. If long distance calls are greater than 5, we then say your long distance calls are 10p. If long distance calls are greater than 5 and you've made less than or equal to 10 local calls, then they are free. But if your local calls are greater than 10, they're charged at 2p each. If the number of long distance calls is less than or equal to 5, then your long distance calls are 25p each and your local calls are 5p each. So let's have a very quick look at that as a Java example. Okay, so I've downloaded the Phone 2 application from the VLE. I've opened it up in BlueJ and I've just give it a quick compile, make sure everything's alright. So first thing we'll do is we'll open it up in the editor just to make sure everything's alright with it. And our class has got our 2 integer instance variables for long distance and local calls. We've initialized those to 0 in the constructor. We've got 2 methods which count up the long distance calls. We've got make long distance call, which adds 1 on to number of long distance calls, and make local call, which adds 1 on to mlocal. Okay. We've then got a method called call count, which does a check on the number of calls made. If long distance and local are set to 0, then it'll tell us that we've made no calls. In all other cases, it will tell us how many long distance calls have been made and how many local calls have been made, and then, like in other examples we've seen, it will call the phone charges method, whereby it will say if the number of long distance calls is greater than 5, it will tell us that our long distance calls are 10 pence. If the number of long distance calls are greater than 5 and we've made less than or equal to 10 local calls, it'll tell us our local calls for free. If we've made more than 5 long distance calls and we've made over 10 local calls, it'll tell us our local calls are 2p each. If the number of long distance calls is less than or equal to 5, it'll tell us then that our long distance calls are 25p each and our local calls are 5p each. So let's just have a look at a couple of examples and we'll work on the long distance calls to show both sides of that argument. So that compiles and we'll create an instance and inspect. Let's just have a couple of goes at this. So we'll do it with no calls at all and we'll do a call count, and quite rightfully it tells us that we've made no calls. So let's do one with long distance calls less than 5. So we'll make 2 long distance calls, and again we'll do a call count. It tells us we've made 2 long distance calls, no local calls, and it tells us that our long distance calls are 25p each and our local calls are 5p each. So let's add a few more long distance calls in, take that above 5, and then again we'll do a call count telling us that we've made 6 long distance calls, no local calls, our long distance calls are 10p and all our local calls are free. Okay then, so just to summarise some of the things that we've looked at today. We looked at compound decisions, and part of those compound decisions involve the use of logical operators, the use of and or, and not. We had a very brief overview of the Boolean data type, which stores the value of true or false or nothing else. We then had a look at calling methods from within other methods just by calling them through the method name. And then we had a very quick look at embedded decisions, where we actually embedded if statements within if statements. And as a very quick note on that, even though Blu-ray sort of does it for us, the layout of our code is very important with embedded decisions, just to make it a lot more readable.